A normal chat completion can describe how to analyze data, but it cannot actually do the math. It predicts text. It does not execute anything. In this video, we build something different. An agent on the Azure AI Agent service that writes real Python, runs it inside a secure sandbox in the cloud, and hands you back both the answer and any chart it produced. We will go line by line, explain every concept, cover the Azure resources you need first, and finish with the pitfalls and clean up the quick start skip. By the end, you can point this at your own data and get a working analyst in about 40 lines. First, the concept. An agent is a language model, plus tools, plus instructions, wrapped in a service that manages the conversation for you. The code interpreter is one of those tools. When you attach it, the model gains the ability to write a Python program, send it to a sandboxed environment that Azure hosts, run it, see the output or any error, and even fix its own code and try again. That loop, reason, write code, run, observe, is what makes it reliable for anything numeric. Instead of guessing the average of a column, it literally loads your file and computes it. And you never manage that sandbox, it is fully serverless. Here is the end-to-end flow we are about to build, so the code makes sense as we go. 1. You upload a data file to the service. 2. You create an agent and attach the code interpreter tool, pointing it at that file. 3. You open a thread, which is just the conversation. 4. You add a user message with your question and start a run. 5. The agent writes and executes Python against your file. And 6. You read back the text answer and download any images it generated. Every step maps to 1 or 2 lines of code, so keep this picture in mind. Before any code, you need 3 things in Azure. First, a subscription with access to Azure AI Foundry, formerly Azure AI Studio. Second, a Foundry project, the workspace that holds your models, connections, and agents, which you create in the Foundry portal in a couple of clicks. Third, a model deployment. You deploy a chat model like GPT-4o Mini into that project and give it a deployment name. The code interpreter works with standard chat models. Nothing special required. A simple test. If you can open the chat playground in Foundry and get a reply, you already have everything you need. The one secret your code needs is the project connection string. In the Foundry portal, open your project, go to the overview or settings page, and copy the connection string. It is a region-specific endpoint. Then your subscription, resource group, and project name, separated by semicolons. Set it as an environment variable so it never gets hard-coded. Then install the 2 libraries, the Azure AI Projects SDK, which talks to the agent service, and Azure Identity, which handles sign-in. Now the code. We import the AI project client, the code interpreter tool, and the file purpose enum from the models module, and default Azure credential from Azure Identity. Default Azure credential is worth understanding. It is a chain. It tries several ways to authenticate in order. Environment variables, a managed identity if you are running in Azure, your Azure CLI sign-in on your laptop, and more, and uses the first that works. So locally, you just run AZ login once and your code authenticates as you, with no keys in source. In production, the very same line picks up the managed identity automatically. 1 line, secure everywhere. Next, we give the agent something to analyze. We call upload file and poll, passing the path to a local file, here ACSV of stock data, and a purpose of agents, which tags the file for the agent service. The poll part matters. Uploading and processing is asynchronous, and this helper blocks until the file is fully ready, then returns a file object. We keep its identifier, a handle we pass to the tool in a moment. If you skip the poll and use the file too early, you get a not ready error. So this convenience method saves you writing your own wait loop. Now the heart of it. We construct the code interpreter tool and hand it our file, so the sandbox will have that CSV on disk. Then we create the agent. The model parameter is your deployment name. GPT-4o Mini here, cheap and more than capable. Name is just a label. Instructions are the system prompt, the agent's standing orders, telling it to act as a data analyst and to write and run Python. Then 2 lines via the tool. Tool definitions tells the model the tool exists and how to call it, and tool resources gives it the actual file. Both come straight off the tool object, so you never handwrite a schema. With the agent created, we start a conversation. In the agent service, a thread is the conversation. It stores the messages and persists between turns, so the agent has memory without you managing any history. We create an empty thread, then add a user message to it, role user, content being our actual question. Plot the 5 most volatile stocks and save it as a PNG. Notice the agent and the thread are separate objects. You can reuse one agent across many threads, one per user or per session, which is exactly how you would build a real application. A message just sits in the thread until you start a run. A run is the agent actually working, reading the thread, deciding what to do, writing Python, executing it in the sandbox, looping if there is an error, and finally writing its reply back into the thread. Runs are asynchronous by nature, but here we use create and process run, a helper that starts the run and blocks until it reaches a terminal state, completed or failed, polling for us. For a script that is perfect. In a web app, you would start the run and poll yourself so you do not block the request, but the work the service does is identical. When the run completes, the results live in the thread as new messages. We fetch them, then ask for the last text message from the assistant. That is your written answer. But the agent also generated an image, so we loop over the image contents and for each one call save file with its identifier, writing the chart to disk as a PNG. Stop and appreciate this. You never imported pandas, never called a plotting library, never wrote a line of analysis. The agent wrote and ran all of that Python itself, and just handed you the finished file. Let us zoom out. When you started that run, the model did not answer from memory. It saw your question and the attached file, decided code was needed, and emitted a Python program. The service ran that program in an isolated container that had your CSV mounted, captured its output and the saved image, and fed the result back to the model, which then wrote your plain English summary. If the code had thrown an error, the model would have seen the traceback and corrected itself, often silently. That reason, act, observe loop is why agents are more reliable than a single prompt for anything computational. A few things the quick start skip. First, clean up, agents, threads, and uploaded files persist in your project after the script ends. In a real app, you reuse them. But for experiments, delete the agent and file when done. A simple delete agent call by identifier so they do not pile up. Second, cost. You pay for model tokens as usual, and the code interpreter bills for its active session time. Cheap for short tasks but watch long ones. Third, the sandbox has no internet and a time limit. It is for computing on the data you give it, not for calling external APIs. And finally, file size and type limits apply, so trim very large datasets first. And that is a complete, working code interpreter agent, every line explained. The full sample is in Microsoft's Azure Samples Azure Samples repo, under Scenarios, Agents, Samples, Code Interpreter. The link and exact path are in the description. Clone it, drop in your own CSV, change the question, and you have a genuine data analyst you can talk to. If this was useful, subscribe. There is a whole series building on the Azure AI Agent service. Now go build it. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.